We are in the last scientific session of the workshop, followed at 11:15 by lunch, which will be in the same place as yesterday. And then whenever you need to head out, please feel free to do so. I will open the session by thanking you all for being here. It's been my pleasure to host you on campus. By everybody repeating or saying, I should say, continuously how amazing and beautiful the campus is, it kind of reminded me how beautiful the campus is. I think I take it for granted because I'm here every day. So thank you all and have safe flights home. I was hoping that Mitra Basu, the program officer at NSF who funded the workshop, would be on Zoom. She's experiencing some technical issues, but I will read to you what she sent me as her perspective of what this workshop is about. This is what she said. One of the information sources we rely on for keeping NSF programs at the cutting edge is the research community. So I'm hoping to get feedback on what are next set of grand challenges for network biology. What are the hard problems there? Is the motivation, driving factor coming from real world problems? How best to shape the funding program and keep it flexible, agile, and above all, make it a living program? The other challenge is to keep the work supported through this program relevant to the CCF division, where this is SAIS within SAIS, where the front, which is her program, the CCF division, where the front and center focus is in pushing fundamental research in computing, algorithm development, and creation of novel technologies. I also want to emphasize the two-way street between application and computing domains. Both must be in a win-win situation. And then she reminded me to, again, mention the importance of the report, the outcome of the workshop. I'll comment on that again one more time. But she wants to stress out that this document will be both for the research community as well as for the program, because inside of NSF, many people will read it, her words. So the goal of the report, I call it report, but it's meant to be not just boring, old-fashioned report that we all have to submit yearly for funding agencies on what we did in our proposals. It's really, I'm envisioning something with Marinka that would be perspective review, survey paper that has breadth but also depth, that will inform the research community on what we should work on over the next decade, and also the NSF, and I can't comment on how impactful it will actually be within either research community or NSF. I will gladly encourage all of you to participate in creation of this document, where Marinka and I will develop the skeleton, the train of thoughts. So basically it would be like for each of you to add whatever you feel you can add to, because I am not an expert on most, if not all, of the topics that have been covered over the workshop. So your expertise will be needed, but that's totally voluntary. And I will, so you're not off the hook yet. You can expect many emails from me over the next month or so. And I expect this report to be finalized within 2 to 3 months tops. So just to give you an idea of the timeline. I had something else to say and skipped my mind, so if I remember it, I will come back to it. But now I will let Marinka guide the discussion. The two of us added already some motivational, higher level questions, and she will also conclude the workshop before we head to lunch. Thank you.
Absolutely. Thank you so much, Diana.
Oh, I remembered the most important goal for us as a community resulting from this workshop should be that we use the discussion here that's happened to process, to figure out what we want to do next in the field. How do we start new initiatives? And hopefully this results in proposals. Proposals being just means to getting funding to do amazing work across institutions on these next grand challenges, whatever they might be.
Great. We have a set of guiding questions, and I'm sharing my screen. Can we put my... Okay, perfect. Thank you. So what we did with Diana is we identified 7 broad questions that we would like to use as guiding questions for today's discussion. So what we hope is that we can discuss here in person. You can comment and also enter some of your thoughts by going to slido.com and entering this code 7347946, which will lead you then to this first question that we have for the discussion today. Yes, I will give you a second. And so this first question is a recurring topic that was discussed over several sessions yesterday and today, and it relates to how can network biology best support collection and analysis of multimodal data. And it was very nicely discussed that in the section this morning on connecting imaging with transcriptomics, possibly with spatial data, and do that for the same individuals to have multiple levels or of data types being measured and then brought together. What would it mean to develop then context-specific, context-dependent, personalized networks and models? What are the challenges? What are the open questions here? And you can kind of, this is the open floor for discussion, so I hope people can start comment and also enter some of your thoughts here in this word cloud. We'll see. Okay. Algorithms. Would anyone like to comment on what does such data for same individuals exist? That's a great question. So what should we do about it? What can network biology community do about it if we are not generating such data? Yes, absolutely. Okay. Please do so.
I think there's this question of always, how much data was enough, right? And I don't think we don't really know. And I think I don't know how, we need to figure out what the question is before we collect data, right? And I think that's sort of, I don't know how to best target that. I mean, except for asking for more questions that we can use to motivate the collection of data to solve the network biology. But it's very different.
But how could the field then support the analysis of such data better than the collection itself? So what is needed? What are the kind of the missing gaps in this area?
So I want to echo that. I think that especially in the data mining community, often we view this data collection as a pre-processing stage. I think that, so maybe we should change that kind of mindset to know what we want to do with data sets, what kind of question we want. I think maybe integrating the data collection together with the downstream task that is maybe that could provide some better solutions. And the other thing I want to mention is also
someone has to use the mic.
Oh, yeah. Thank you.
So the other thing I think also mentioned in our topic is on the active learning. I think we mentioned that in terms of how to use active learning for conducting more effective experiment, but maybe I think the same kind of methodology can also be applied to the data collection for the active data collection. But that also requires to better understand what kind of question we want to answer to bring the downstreaming, the data mining task early on, better integrate with the data integration itself.
Great point. What about the data annotation or label? Thoughts? Comments? Okay, so let's see what are some of the answers that we got here. Defining optimal data sets, multi-omics on paired samples, active learning strategies, collaborations, optimal experimental design, which probably relates to active learning that was mentioned, software stack, which is important, finding unifying factors between modalities. Okay. That's also a nice view of it. Any other thought and comment for this question? If not, let's kind of then go to the next one. Yesterday there was a very interesting, in one of the sessions it was pointed out that underlying many of applications in network biology are really the similarity metrics. So at some point we need to decide what kind of similarity is being captured in a specific application problem. For example, when we are working with ML models such as GNS, one needs to design when do we want two nodes, for example, to be embedded close together in the embedding space. And so that inherently requires the designer of the algorithm to specify what kind of similarity they want to capture, or we need to specify metrics to quantify co-expression networks when we are constructing either relational or correlation networks. So there are many open questions here in this area that were pointed out throughout the last 2 days that relate to modeling correlations versus causations, developing application-specific techniques versus general techniques. Are we essentially designing a new similarity metric for every new data type or for every new application? How to establish best practices, how to develop generalizable techniques that can score similarities? Are there some kind of fundamental gaps that that research would need to be done over the next 5 to 10 years that could allow us produce generalizable techniques for these questions? Is that something that one would even want to consider? So this is the question open for discussion now. Stop with empirical random decisions. I think many would like to do that. But what else is there? Okay, collecting longitudinal data, better way to represent pathways as biologists understand them, metrics for reproducibility and robustness, selecting metrics based on target audience. That's great. Any comment in person? It should be more like an interactive discussion as well.
Yeah, can you hear me?
Yes, we can hear you.
Jerry. I just wanted to make a quick comment about causation. So
Yep.
when we have causal links, we have to understand that they don't tell us anything about the biochemical mechanism. And also when we have, if you have biochemical mechanisms, you can kind of infer causality, but it's hard to go the other way. When we represent gene regulatory networks, you need to understand that those are biochemical paradigms that don't necessarily, it's not the same type of causality edge.
Thank you.
So the difference between causal networks and physical networks or molecular networks.
So what's the goal of the similarity metrics? And I think that will help guide the answer a little bit more. I mean, we talked about, some algorithms we don't even really look at the edges. We just use it to get nodes,
Yes.
right? In which case, Jacquard kind of works, right? I mean, again,
Yes.
what do we need? What do we mean what is the goal of the similarity? And then, or what are the goals? And then I think we can sort of bracket off which ones metrics are best.
Yeah, that's part of the question. So if you think of similarity metrics, they are being used to construct the network. So which then means how to define correlation, how to measure similarity between nodes. That when the similarity is high, one would decide to connect two nodes in the graph, or in other contexts when we are generating embeddings or representations, one need to design when do we want for two nodes, their embedding vectors, the resulting vectors to look similar, meaning the dot product between them would be very high. So perhaps the most obvious way to think of it is, we want two nodes that are directly neighbors in the network to have kind of high similarity, highly similar embeddings. But there are many other ways how to do that, and now all of them are kind of application specific. Yes, go ahead, Diana. Yep.
Oh, I was just going to add, in terms of similarity of nodes when they're proteins, I mean, sometimes they have dissimilar annotations, whether it's one's upregulated, the other's downregulated, but they're in the same, they're working on something together, or they have like opposing effects to each other. So sometimes, we have to think also about similarity. I mean, sometimes we have to think about dissimilarity as also being indicative of, some shared relationship.
Oh, great point.
So just following up on what Mona was saying, I think that's what Mona brought up is very, very interesting. So we often think about this, even just think about protein-protein interaction edges. We want, if we have an edge, as Marinka was saying, we want the neighbors to be similar. However, if you think about these edges, they have actually different meanings, right? So you could have an inhibitor, I often use CDK4, right? CDK4 needs to bind cyclin D to be active, and it also have a lot of P15, P16, P18, a lot of inhibitors, and it also binds RB and a bunch of other things as downstream effectors. Those edges mean very different things. So if you have mutation, for example, in melanoma, the mutations are focused on the binding side of the inhibitors, because then CDK4 is a loss of function on the molecular level, but it's a gain of function at the cellular level because CDK4 becomes constitutively active, actually in specific cell lines, and depends on which actually inhibitors are present. So those edges are actually not the same, right? So the inhibitor, I don't know whether we want the inhibitors, the co-activators, and downstream effectors to be similar. Depends on the underlying network and the purpose of the similarity matrix.
Point. Yeah, it certainly seems predominant approach is still to assume some form of homophily in the network, meaning that if two nodes will be connected by edges, there will be some kind of shared annotations or shared labels that they will have, right? And that informs the development of metrics in many ways. Perhaps there's a way to advance that. Okay, let's see what are some of the answers here. People are suggesting including parameters to leverage the stochasticity, modeling pathways, the need for more benchmarking studies, reproducibility, metrics, interpretability, target design of metrics informed by target audience, target tasks, which was also very nicely mentioned here. So kind of similar recurring solutions as proposed for the previous question. So, and kind of, I think that will all can be brought together with the next one, which is a bit broader question related to also what Mitra mentioned in her message, which is what kind of initiatives, what kind of campaigns could best support network biology, network health in the next decade. And so would like to really think very broadly here, data standards, model standards, analysis guidelines, data sharing and privacy was mentioned in several of the sessions in the last few days. The question of benchmarks, performance evaluation was also a recurring topic yesterday, this morning. Are there existing tools that we have but are not leveraged to the fullest extent? For example, the session this morning mentioned some of the security, privacy tools that exist in cryptography that could be used. There are perhaps benchmarks or data standards or ways to, or software stacks to represent very large-scale networks in biology as well that can be adopted from other disciplines. So this is open for discussion now. And if anyone would like to make a comment, that's also greatly appreciated with microphone, so that we don't just sit quiet here. Yes.
Well, so I think that perhaps what's missing from current network models is the network dynamics.
Yes.
So, and having various types of perturbation data, more also perturbation or time dependence data, phenotype dependent data will help to guide this development of the method that will utilize network dynamics more fully. Of course, it's difficult to have perturb everything, but at least, have some data set that can be used by algorithms design to push the, at least computational part forward.
Someone else?
I just want to say something, just following previous survey about the simulation and currently standard and Teresa's comments. I have such kind of experience when I trying to sell my own tool developed, right? I was asked by review to compare with the existing tool. And I apply to existing tool using the real data. They don't feel satisfied. They want to also use the simulated data. And the funny story is existing tool has their own simulated data published. And I apply my tool, the two tools on two different simulated data. And you can expect it. The simulated data generated by tool A got best performance of method A, and the same for method 2. So therefore, the benchmark for all the simulation data or for ours to compare performance is very, very important.
Yeah, I agree. Great point. And really the question is then, what is a benchmark? What it requires, like a real-world data set, a simulated data set, ground information.
Yeah, I want to pick up on that. I wrote something that was somehow not able to be displayed. I think we need some best practices or guidelines on evaluation of models. There's many, yesterday when Lenore was talking, I just got reminded how, let's say, in link prediction evaluation, let's say you have a PPI network. If you take the positives, many of them will be linked to the high connectivity nodes. But if you take randomly negatives, they will be predominantly coming from nodes that have zero interactions, because there's more nodes that have no interactions, right? So then basically the degree distribution of the graph is a perfect almost predictor. You can't beat it. But there's so many problems like this in network biology that I think it would be very useful to think about some kind of norms for the field along those lines.
That's a great point. In one of our recent studies, we actually correlated node degrees with NIH funding cycles. And there is a positive correlation with what disease areas are being funded more during a particular decade, and kind of just the amount of data, and therefore node degrees and connectivity in the graphs. So.
Yeah, I agree with this. I think it's very important.
One thing I think that'd be interesting for the community to think about is algorithmic approaches to figure out what to prioritize for data collection. So whether it's data from certain populations or whether it's data about certain functions, or just to think about whether there's a way to formally, not say I need this data, but kind of for these class of problems, this would be the most useful thing that would help us in terms of kind of getting big performance improvements, and whether there's algorithmic strategies to kind of guide that.
Yeah. Yeah.
I will loudly stay behind this comment, even in front of NIH representatives. NIH needs to start appreciating computational research. Do I need to say more? It's frustrating to serve even on an NIH panel and see how much they value creating a database that combines 5 different data sources and data generation, but not methods for analysis of data. And while they do have calls that imply that they want development of new methods, they have destroyed my morale on never applying to NIH again. So
that's a great segue to the next question that we have. Thank you, Tiana. we'll go here. So you just need to enter a different code. It's 4123164 this time. It's really asking about what initiatives or campaigns are recommended to support the field in the next decade. It's training education across disciplines, early career initiatives, DEI. What is the relationship we see between network biology and computational biology, network biology and other communities? Broadly, data science, data mining community, AI, ML, biomedical research, and experimental design, as Tiana was referring to. Are there any ethical gaps that we see are specific or unique to network biology that one should address in the next decade or so? Okay, good point.
Is questioning this or is this statement this is true?
Oh, none of these are states. Oh, that's
Computational biology is subfield of computational biology is subfield of computer science.
That was a statement. I think, I think computational biology has to be taught as a field of biology for everyone to understand. For biology, if we're trying to understand a cellular pathway, we have to understand the ways that we're measuring the cellular pathway, right? And I think, and yes, we can understand microscopy and Westerns and sometimes even ion mobility mass spec, but we also have to understand, the algorithms that are going in. And it's just one part of the larger picture.
I think,
Go ahead.
can I, is there a way to raise my hand or can I speak at some point?
Go for it.
I think that there's a real need that's been identified in both NIH and NSF for gaps in training. We recognize that people coming from the CS side and people coming from the NIH side both need to sort of cross-train. And I would be super excited about a joint NIH-NSF training program that really thought hard about what skill sets and exposures people would need to do what we do, because we're really in the middle, right? Sometimes we get hurt in the grant funding by the fact we're so far in the middle. But I really think everybody is saying we need people who are trained like us. And I think it would really make sense to think about how to design a training program that would work to give people both sides of the picture and so they can make really great principled contributions.
Yeah, so I just want to mention, I think my overall impression of the workshop, I think we talk a lot about like how to better integrate data, how to design better graph neural network models. So the overall idea, my impression, we want to improve, generally speaking, the accuracy of our AI model. I think this is indeed very important, but so what about something like beyond the accuracy? I think we touched on, like from the last session, we talked about the equity, the fairness issue, the privacy. I think maybe broadly think about like what other things we need to think about in the network biology beyond the accuracy.
Great point. Most models are optimized for predictive performance, but especially we see them more and more used in high-stakes decision-making problems, whether that's for experimental design or medical settings. There are other aspects that are important.
I like one word, calibration. Calibration. In addition to accuracy. That's all.
I kind of +1 on that. Neural networks are so notoriously bad at that. Tiana.
So I want to touch back on the issue of training and what computational biology is. And I don't think there's two people in this audience that were trained the same way. In my experience in my department, which is computer science and engineering, candidates we've interviewed in computational biology are judged as either being machine learning people who just hide bio labels and try to predict them, or and we do not interview purely wet lab people in my department, even though they apply sometimes, simply because there's no way that they will be judged to contribute to computer science field per se. or they're really focused on biological problems, even though they develop algorithms, their vocabulary is not can be understood by many non-computational biology, computer science faculty. When I try to recruit students in my department, first time I taught a course called Algorithms for Biological Networks. It went horribly, because students who were interested in bio questions hated the algorithms part, and students who wanted to learn algorithms hated the bio applications. So I just revamped the course to call it network science, and I still teach 70% of the same material, and it's beautiful. So my comment / question here, and I don't know if anybody has answers, is we typically have students, at least in computer science department, in my department, who just want to do deep learning data mining, and they will evaluate in the bio data, but they're not really hardcore interested in bio questions. And then you have students in bio department who want to do bio questions, and they'll gain skills of how to use data science methods, but then they go back to random choices of which methods and which parameters to use just to answer a question that they need to answer. How many people, population-wise, are actually interested to get hardcore interdisciplinary training? How do we convince students to want to know how to develop deep learning models? I'm using deep learning as an example, while also being interested to answer bio questions. Is that feasible? Because unless we can get people motivated, there's no way to design training programs accordingly.
Thank you. Yeah. Also, let's think about, like, are there questions that are specific to network biology? Do we see the same kind of problems and issues as in general computational biology, or are there specific challenges unique to network biology as well?
Well, I don't have an answer to that, but I want to support what Tiana said. I think it's super important, and Lenore said it as well. We are in the middle, and we need opportunities for people who are in the middle to have workshops like this, to be able to bring together people, even from computer science, maybe world, who might start caring about actually solving a biological problem, etc. And so this type of activity, I think, on the educational side, not necessarily network biology, but it could be, in data science, or however we phrase it, we should keep doing that.
Part of training education is also then to have kind of code bases and tools and stacks and software. And kind of yesterday was very nicely mentioned, I think, by Alex when he was giving his presentation on, and there was a discussion around the use of hypergraphs and why do we use them more broadly. And it seemed like the impression was, well, things become quite complicated fairly quickly. We not necessarily have robust implementations or code bases that are as easy to use as some other existing tools in this area. So any thoughts on that, or kind of are there limitations in methods, technologies, kind of stacks?
It's a sort of a tongue-in-cheek answer. We do have a great software base code base for hypergraphs. The only problem is only Anna and I know about it. But it's out there on GitHub. Please try to use it. Let me make another comment regarding the previous point, and that relates to software development. I think we talk a lot about benchmarking. I think it's very useful and important. But I think what we should do is continuous benchmarking to the extent we can. Otherwise, the benchmarking happens at a point of time. A dream challenge happens at a point of time. You have results and observations based on the set of algorithms that have been evaluated. But as we said, new methods of evaluation will appear, new data sets will appear, new algorithms will appear. So if you can develop frameworks where you can perform benchmarking continuously, just like you do continuous integration for software, I think that might be one step forward.
I guess I want to say a little bit as an old timer that, in the beginning of computational biology, it was like very attractive to students to enter computational biology because it was like one of the first kind of like what they thought of then as like big data sets that they could do fun stuff with. And now everything has kind of changed where there's all kinds of huge data sets that are more easily accessible to students. So it's easier for a student to think about an image or to think about language than it is for them to learn, biology. And so I think that if there is, like, it sounds like you're doing some of this stuff by building these data sets that are accessible to people who don't actually know much biology as a way to kind of get into the field and then end up caring, that is sort of a way to bring people into the field and attract young people.
So pulling on those two threads, I mean, I think that there is this idea of making, again, software more accessible, right? I mean, I think we can always say, oh, I put my code on GitHub, but is it containerized? Does it work with standardized metadata? Does it work on Dream Challenge data? I mean, all the Dream Challenges are now Dockerized, so they are continuous benchmarks. And I think, there is this way to be like, okay, so now, how does one hypergraph tool compare to HyperNet X, right? Like there's other things, and I think that those are simple things that we can do to make things more accessible so that, again, the burden doesn't, you don't have to develop in C++ or Fortran, but you have to run a Docker command to compare your new method, right? I think things have moved along in software a little bit.
That's a great point, but then sustaining that software requires resources and kind of both in terms of data storage and kind of AWS cloud credits and things like that.
I want to switch gears a little bit, and I don't want to open this can of worms too much, but diversity, equity, and inclusion. 42% of in-person workshop participants here have been non-male, and I worked really hard to make sure that happens. So if somebody says there's no diversity, in this case I'm referring to gender diversity, they're wrong. I've done really hard effort to get ethnic minorities here, and that's much more challenging, partially because the underlying population from which to draw the candidates is even sparser than from gender perspective. I just want to encourage everybody, no matter what your gender is, most of us statistically are biased towards very, very many different issues. When there are awards happening, when you're going through faculty search, please nominate candidates, and for every non-minority, be it gender, ethnic, or any other minority, for every non-minority candidate you nominate, make sure you nominate one minority candidate, please. Thank you.
Okay. Yeah. So picking up on some of the diversity issues that Tiana mentioned, I think that the way that the NSF does funding actually makes it difficult to enforce kind of diversity issues. So if every person funds 2 people, then it's hard to say I'm gonna, it's hard to hold them to it and say, oh, you don't have any women who you've mentored. But if you do a training grant, which is more like NIH style, and you have 20 people and they go with a department, then you can say, hey, you don't have any minorities in your funding, people that you're funding. You don't have enough women, and so I don't know if that's something that can be passed on.
It can be yearly evaluation per se, but over a period of time.
Yeah, so they need to do something different. In how they do that. So, the NSF makes you write a broader impact statement about what you're going to do, but then I don't know if they hold you responsible and say, I've had 20 trainees and 8 of them are women, or 0 are women, which is, sometimes the case. So I think the funding agency should also kind of figure out a way to enforce some of these diversity issues.
Thank you. Any additional? Yes.
Yeah, I want to talk a little bit more about this diversity issue. I think one thing is that although it's not optimal, obviously not anywhere close to optimal, biology, the field itself is more diverse than computer science. So I think this speaks to also about training accessibility also, which is that it is in this context, it's really important for the growth of the field to become more diverse, to think of computational biology really as a subfield of biology. And make training in computational biology more accessible to biologists, right? Which is that there are 2 ways of teaching computational biology, which I think is, I have experience in, Tiana was talking about one, and then I have experience doing the other, which is that a classroom full of students who are really invested and interested in biological problems, who want to learn computational tools and techniques to solve those problems, versus people who are really interested in algorithms and want applications, right? So I think these 2 are completely different things, and it's really important to make training education accessible to both groups. Right? And I think part of this is also that, I mean, I have sort of some experience with this, the following thing that I'm going to say, which is that I think there is this problem with, physics, mathematics, and potentially a little bit in computer science, which is this notion of gatekeeping, right? Which is that you want to see that someone who's interested in you sort of entering this thing, but without this formal training of a strong degree in any of those fields, is actually a big problem. But computer biology has been one of those areas where I love being part of this community, because I think as a group, I think this field also recognizes, which I also strongly recognize, that good ideas can come from anywhere and from anyone. So I think it's really important to sort of embrace this as a group and then really remove as many gatekeeping processes and obstacles as possible and let anyone from any background enter this field.
Thank you. 4 more minutes? 3 more minutes. Any final comment, question? Then we can move to the next question. Let's do that. So we have the last series of 3 questions that are somewhat more methodologically or algorithmically or oriented and research oriented. Sorry? Oh, we have just 3 more minutes, so let me pick one. Okay, I'll pick this one since it received lots of attention yesterday. So it relates to this perhaps seeming dichotomy between, on one way, discrete combinatorial graph theoretic techniques, on the other hand, AI ML models. For example, think of yesterday we had the discussion of subgraph counting versus deep learning. Like at the end of the day, are both kind of paradigms have the same kind of limitations at their core, or not? Are there ways that are techniques from discrete combinatorial space and algorithms that can help improve and advance deep learning models and vice versa? So are there important directions without which we really cannot imagine the future of network biology being successful, that are at the nexus between combinatorial graph theoretic techniques on one end and kind of more statistically oriented or machine learning models on the other end? Any comments, thoughts? Pedia, yesterday you had quite some suggestions.
Yeah, I was like.
Okay.
Yeah, I do know there is some work that is started in this area, but some sort of both theory that would unify the two and to the degree possible, as well as empirical studies on performance, I think will both be needed in both of these fields. And one can also imagine, deep learning now can incorporate, discrete optimizations as part of its engines. I think there is actually quite a bit that could be done to even integrate it, to not just understand and unify them theoretically.
Absolutely. I really liked recent work at NeurIPS, for example, showing how one can solve some of the shortest path calculation problems or salesman problems with differentiable learning. Far away from biology at this stage. Any other final comments, thoughts before we? Daisy? No? Okay. Great. So let's just see what are some.
Can you comment on your opinion on this? You kind of did it yesterday,
but. To me, that's one of the perhaps most exciting questions for the future. I mean, more in the sense of really finding what are the right inductive biases to include in our models and moving away from much of existing work, which is adopting GNNs or ML models that were designed for other types of data and problems, and asking what kind of principles or inductive biases do we need to integrate into these models. And we see that with some of publications coming out that are in the sense of biologically informed models that are trying to either bring mechanistic principles into the neural network design or visible neural networks, for example, by Tri-Ideker in his group, which is essentially a very nice example of that kind, I would say, where they are essentially defining the architecture of a neural network to be somewhat encouraged to be similar to the structure of gene ontology graph. And sort of that's one way how to bring then the structure of prior knowledge close to a differentiable machine learning model, deep learning model. But I see here there are lots of kind of great thoughts as well about the need for empirical studies on performance, uncertainty quantification, questions regarding interpretability. We hope that working in this area when kind of reconciling these algorithms can kind of help with interpretability and producing generalizable models that are then easily transferable. Accuracy versus running time, yeah, really important point that we discussed yesterday as well. Okay, since we are running out of time, I'll stop sharing the screen. I will stop this here. So some of concluding remarks before we wrap up the workshop is, so first I would really like to thank to Tiana. She did an amazing work. And Harriet. So Tiana and her team and Harriet really did great work getting us here to Notre Dame and taking care of us over the last 2 or 3 days, feeding us well, being here in a very nice venue and kind of enabling all those kinds of interactions that hopefully will stimulate lots of collaborations or synergies in the future. So, and the other point is, I think while we don't have the NSF program manager here with us, I think she would also like to express her thanks to all of you for kind of participating in this workshop and really they're looking forward to what kind of recommendations and guidelines and we can provide that could inform then the future of kind of their thinking at NSF as well. So Tiana and I will be in touch regarding that and hopefully your answers to some of these questions as well as the discussions over the last 2 days will be really helpful in shaping that document and report to be shared with NSF. We'll be in touch. Okay, great. So I think this concludes the workshop. There is the lunch in the next room. And I wish everyone have a great rest of the day and safe travels back to your home destinations. Thank you.